Dear students, you are watching Study with Sheraz, and in today's lecture we are going to discuss about the Fajans rule. Basically, in the previous lecture we have discussed about the polarizing power and the polarization and polarizability. If you have not watched that video, then go and first watch that video, then come to this video so that you can have a better understanding about the factors affecting the polarizability and polarizing power. Basically, Fajans rule are a set of rules that discussing the factors affecting the polarizing power and the polarizability. First factor is the charge on ions. If we talk about the cation, or if we talk about the polarizing power, higher the positive charge on a cation, greater would be its polarizing power. If we have number of cations that are given here and we are asked to compare the polarizing power of these cations, so the cation with the greater positive charge would be highly polarizing, that would be having greatest polarizing power, and the cation with the smallest positive charge would be having lowest polarizing power. So C plus 4 is having greatest polarizing power, then followed by the B plus 3, then followed by the beryllium plus 2 and lithium plus. So carbon cation is having plus 4 oxidation state at the charge, so its polarizing power is greatest of all the cations. If we talk about the polarizability of the anion and the magnitude of charge, so greater the value of negative charge on an ion, greater would be its polarizability. We have 4 anions, that are C minus 4, N minus 3, O minus 2 and F minus 1, and we are asked to compare the polarizability of these anions. So anion with the greatest negative charge would be having the greatest polarizability. So C minus 4 is having the greatest polarizability, followed by N minus 3, O minus 2 and F minus 1. C minus 4 is having greatest polarizability because of the greatest negative charge. Next factor is the size of the ions. Keep in mind that we can only compare the size of those ions that are having the same charge, same negative charge, same positive charge. With same positive charge, smaller cations have greatest polarizing power. If we have number of cations and the positive charge of all the cations is same, so that cation which is having the smallest size would be the greatest in polarizing power. We have 4 cations, all are having same positive charge plus 2, and we are asked to compare the polarizing power of these cations. So beryllium is having the smallest size, so its polarizing power would be greatest, and strontium is having the greatest size of all these cations, charge is same, so strontium would be lowest in the order of polarizing power. If we talk about the polarizability, with same negative charge, anions with large size has high polarizability. So if we have number of anions, the negative charge is same, so the anion with the greatest size would be having the greatest polarizability. If we compare these 4 anions, charge is same, the iodo is having the greatest size, so it would be having the greatest polarizability. Fluoro is having the least size, so its polarizability would be least. The next is the effect of electronic configuration of the cations. So keep in mind, for this factor we are only going to discuss about the cations. So the cations with 18 electron configuration, that's shown by the NH2 NP6 N-1D, have greater polarizing power as compared to those cations that are having the 8 electron configuration, and that's shown by the NH2 NP6. What does it mean? It means that the cations which are belonging to the transition metals, so the cations belonging to the transition metals are having d orbital, N-1 d orbital involved in the electronic configuration. So the cations that belong to the transition metals are having greater polarizing power as compared to those cations which are belonging to the typical elements. So example given here is the polarizing power of the silver plus is greater than the polarizing power of the potassium plus, and you know that silver belongs to the transition metal and potassium belongs to the typical elements. So transition element cation is having greater polarizing power as compared to that of the non-transition. The reason is that because of the poor shielding effect of the d electron or poor shielding effect of the d subshell, the effective nuclear charge, or you can say the nuclear pull, in case of the cations of transition metal cations is much greater. The hold of nucleus on valence electrons in case of transition metal cation is much greater as compared to that of the typical elements. So a transition metal cation can strongly attract the electronic cloud of the anion as compared to that of the typical or normal element. First point is the trends are the variation of polarizability and polarizing power in the periodic table. So first of all, we will talk about the polarizing power. So polarizing power increases within period. From left to right, polarizing power increases. Why this is happening? This is happening because of two factors. From left to right, size decreases. From left to right, positive charge is increasing. So because of these two factors, the polarizing power of the cations increases. So this order is consistent with this concept. C plus 4 is having the greatest polarizing power, and when we move from left to right in the periodic table, the polarizing power of the cations is increasing. So carbon is having the greatest power, boron is having smaller than that, then beryllium, and then lastly there is the lithium. If we talk about the variation in group, the polarizing power decreases down the group. Why this is happening? This is happening because down the group the size of the cation is increasing, and increase in size of the cation decreases the polarizing power. All these cations are having the same positive charge, but as the size is increasing from beryllium to strontium, the polarizing power of the cation is decreasing. Next we talk about the polarizability trends. So if we talk about the polarizability decreases within period. From left to right, polarizability decreases because from left to right the size of anions is decreasing, as well as at the same time the negative charge is also decreased from left to right. So C minus 4 is having the greatest polarizability, followed by N minus 3, O minus 2, F minus. So this is consistent with this trend. And lastly, if we talk about the group, the polarizability increases down the group. Why? Because down the group the size of anions increases, charge remains constant. If you talk about here, the iodo is having the greatest size and the fluoro is having the least size. So down the group the polarizability of the anions with same charge increases. So this was all about the Fajans rule. If you have any question, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.